Good afternoon, everyone. Thank you very much for coming here for the AWS Summit today. And in this session, we are going to talk about how do you build a serverless data lake on AWS. My name is Unni Pillai. I'm a solutions architect with the Amazon office here in Singapore. And on a day-to-day basis, I get an opportunity to work with a lot of customers who are building their data platforms and machine learning and artificial intelligence applications on AWS. I've also been honored by having Daniel Muller, who is the head of cloud infrastructure for Spuul, who will be coming and sharing his story about how did he build a data lake and how is this company benefiting by building a data lake, right? So everybody is talking about data lakes, right? So it's become like one of the biggest buzzwords for the year 2018. Let's take a look at what a data lake is, right? So data lake is an architecture pattern that you put together where you'll be able to bring in data from different sources, be it your traditional databases, NoSQL databases, or completely unstructured data like log files or IoT information, bring it to a center place where you'll be able to store the data and make it available for processing and consumption for multiple users, right? So this is what a data lake is. So how does it differ from a data warehousing system, right? In a traditional data warehousing system, what you look at and what you build is basically a set of databases which will have the data in them, and then a data analyst or a database administrator, BI professional, will connect to the database, pull the data, and then build reports, right? But it is very custom. It is very specifically built for reporting and BI and stuff, right? But now the needs of data teams are increasingly changing constantly, right? What does that mean? So if you think about 10 years back, like there were hardly any data scientists in the companies, right? And now if you look at it, there are like data scientists everywhere, right? And they need access to raw data. They need access to data that is clean, that is raw, and they can draw insights out of it, right? They can innovate using the data that they have and build machine learning models, artificial intelligence models to go ahead and innovate for their customers, right? So with that, let's take a look at what are the challenges that are being faced by data teams across the globe, right? So first of all is the amount of data that we are being exposed to on a day-to-day basis is increasing, right? So 10 years back, a terabyte of data was like huge, right? Now we are talking about petabytes, like starting with few petabytes to hexabytes as well, right? And the sources from where this data was coming in is also changing on a day-to-day basis, right? So you had traditionally had only database engines that were giving you data, right? Now you have data coming in from log files. Now you have data coming in from social media, IoT sensors, and stuff like that, right? So I wear a smartwatch, right? That is sending my information about my activities, what I do, what is the heart rate, and everything to the cloud, right? And there they analyze it, and then they give me recommendations based on I should be working out more, or I should be standing more, or whatever, right? So the amount of data is increasing on a day-to-day basis, right? And using one data store to store all of this data, using one mechanism to collect all of this data is not sufficient, right? And that's where we need to have a data lake architecture that we'll be building to ingest data from different sources, keep it in a centralized location, and then analyze it from there, right? So the second is who are the consumers of the data, right? So I spoke about this earlier. The consumers of the data are also changing on a day-to-day basis, right? So you have you previously had data analysts and BI professionals who would access the data, build reports, do charting and dashboarding on it, right? Now you have data scientists who need access to the data in raw format. They process the data, and then they make it available for consumption, right? And then obviously now every company is interacting with other companies, and they want to build integrations, right? And for that integrations, it's not, I mean, 10 years back, the way one bank would be sending data to other bank would be placing it in an FTP server, right? And then the other bank would come in and pick it up from there, right? It doesn't work anymore. It's not scalable, right? It's not fast enough. So what do you do now? You create APIs, right? So everybody is talking about APIs. Everybody is talking about serverless computing, right? And how do you do this? Is by building API, building a data lake, building an API abstraction layer on top of the data lake, having your third-party integrators connect to the API and fetch the data in the format that they need, right? So with that, that is the diversified set of users, right? And obviously, the way these users interact has also changed, right? So data scientists use tools like Zeppelin Notebook or Jupyter Notebook to connect to the data and extract the data and transform it, right? And obviously, you still have your BI tools like Tableau, QuickSight, Qlik, and stuff like that, right? Where they'll be connecting, they'll be drawing and visualizing the data. So when you think about the data lake, it should solve these problems. But while it's solving these three problems, it should also have some characteristics, right? So first of all, as I said, it should be able to collect any kind of data, right? So you should be able to collect any kind of data that comes in. So it should be structured data, unstructured data, semi-structured data, right? So any kind of data. It should be able to ingest videos, audios, and pretty much everything under the sun, right? With that, you should be able to give access to the data scientists or business users of the data in a way that they want, so that they can dive deep, and the flexibility of access where they should be able to access it in the form that they want, right? So if a data scientist requires access to raw data, like in text format, right, they should be able to get it. If there is a business user who only is interested in aggregated data, you should be thinking about aggregated data. Like you should be thinking about making that aggregated data available, right? And last but not the least, if you're spending time building an architecture that is going to last for long with your, together with your business, you want to build something that is future-proof, right? You don't want to build something today that is going to become obsolete after 3 years, right? Because otherwise that will end up, instead of innovating, you will end up collecting technical debt, right? You don't want to be in a situation where you have collected technical debt, right? So that's where building something that is future-proof is important. When I say future-proof, two things come into my mind, right? First, everything should be secure, right? Otherwise, nobody's going to use it, or I'll not be happy keeping my data in there because it's not going to be secure, right? The second is it should not be costing me huge amount of money. So it should be cheaper to run, right? So I need something that is cheaper to run, and I need something that is secure, right? So these are the two things that come into mind when I'm thinking about future-proofing. So throughout the session, what we'll be doing is we'll be taking an example of a customer or like a company that is building, for those of you who have come from Craig's session before lunch, he spoke about how there's a headphone manufacturing company that is like a smart headphone manufacturing company that is generating information, that is collecting information and sending it to the cloud for analytics, right? So we'll be sticking to that example. We'll be looking at emulating some sensor data. We'll send it to the cloud, and this is the architecture that we want to build, right? So we want to build a data lake architecture that will be serverless in the first place. Why serverless? Because we are living in the 21st century and it's 2018. We hate servers, right? So the second is it should be able to ingest any kind of data and store information, store unlimited amount of information, right? We should be able to figure out what is the data, right? I'm going to dump the data into the storage, but I want to have the system to be intelligent enough to go ahead and scan that data. Once the data is scanned, I want that to know what is the data. That is, I want to capture the metadata, and then go ahead and analyze that data and visualize the data after analytics, right? So this is what the journey that I want to take you throughout the session, right? So we are going to use this diagram as the anchor throughout the session, right? So on the left-hand side, what you see, like my left-hand side, also yours. So on the left-hand side, what you see is a set of devices that will be sending data to the cloud, right? So obviously, I don't have like hardware devices here. I'm going to use a Python script that is going to, or a web interface that is going to push the data to our ingestion mechanism, and then have the data transform and visualize, right? So let's take a look at how do you ingest the data into the cloud, right? So depending on what is the type of data that you are dealing with, right? Depending on what is the type of data that you are dealing with, how do you bring in that data will also differ, right? So if you have, let's say, 50 terabytes of database that is sitting in your on-premise environment, right? Or some other cloud provider that you want to bring into AWS for analytics, right? So it won't be wise to copy that over the internet, because 50 terabytes, it will take forever to copy that, right? So we have a solution called AWS Snowball. So Snowball is a hardware device that is like knee length, like my knee length, and you can, there is a demo device outside at the booth, so you can go ahead and take a look at that. But it's an offline device. You can bring it into your data center, plug the device into your servers, move the data, and then ship it back to AWS. and we will bring that data into the cloud, right? We will bring that data into S3, and you'll be able to use it, right? And similarly, there are different ways how you can connect. If you want to connect your on-premise infrastructure to AWS and have a persistent connection throughout the time, you can use AWS Direct Connect. So Direct Connect is a dedicated network line that will be pulling from your data center to our connections, and you'll be able to have a dedicated network bandwidth to have that communication, right? And then obviously, in this case, we are looking at very fast-moving data, right? We are looking at thousands of devices that might be connecting and sending information. So we will be using a streaming service. So the streaming service that we'll be using today is called Amazon Kinesis. So Amazon Kinesis is a real-time is a service that lets you build real-time applications on AWS, and it lets you collect terabytes and terabytes of data in an hour at a really fast pace and a really big volume, right? So Kinesis Streams is a fully managed streaming service. On the other hand, there is Kinesis Firehose. So Firehose is a managed service similar to Streams, but what it also gives you is it takes the data and it delivers the data to an endpoint, right? So you can tell Firehose that, hey, Firehose, I'm going to dump data into the pipe. Can you deliver that data into my data warehouse, right? It will be able to deliver that data into Redshift, right? So it will be able to deliver the data into a specific endpoint that you mentioned during the configuration. The third service that we have as a part of the Kinesis family is Kinesis Analytics. So if you think about Kinesis as a pipe, that is a pipe from which data is traveling, Kinesis Analytics gives you a glass window on top of that pipe, right? So what it gives you is it gives you the ability to run SQL statements inside on top of the data that is going through the pipe and analyze the data using SQL statements, right? So you'll be able to get the data back. You'll be able to get the data back as and when the event happens, and you can take an action. The next service that we have in the Kinesis streaming, in the Kinesis family, is video streams. So video streams is a service that lets you capture video frames, send it to the cloud, and have that analyzed using your machine learning or image recognition models that you have built, right? So let's take a look at how will this fit into our architecture. So this is how Firehose works. You have the data on the left side. The data comes in into Firehose, and you can specify any of these 4 endpoints. You can have the data sent to S3, which is our highly scalable and durable object store. You can send that data to Redshift, which is our data warehousing technology, or you can store that data directly into an Amazon Elasticsearch cluster. And or if you're using Splunk, you can directly have that data delivered into Splunk as well, okay? So this is how it affects our architecture. We have the data. That data goes into Firehose, okay? The next organic thing to do is, now I've collected the data. I need to store the data somewhere so that I can have that analyzed, right? Let's take a look at what are the storage options available. So in this case, we'll be using Amazon S3. Why S3? Because we're building a big data system. And with big data system, one of the most important things is to make it future-proof, we need to focus on cost, and we need to focus on security. Amazon S3 gives you unlimited amount of storage. You can store unlimited amount of objects in it, and you can have security that is security of data at rest using encryption, and you can have security of data in transit using SSL, right? So you have checkmarked all the required things that you need in a big data storage system, right? And that's why I'll be using Amazon S3. So this is how it looks in our architecture. So we have collected the data, put the data in Firehose. We are storing the data now in S3. So now what I'll do is I'll go to my laptop and show you how are we going to generate the data, put it into Firehose, and store it in S3. So I'm going to run you through a live demo. So let's pray to the demo gods that everything works well. The guys on the 5th row, can you give me a thumbs up if you are able to see the font properly? Cool, perfect, thank you very much. So this is my AWS console. What I'm going to do is look for the service called Kinesis, and I'll open Kinesis console, right? And I say get started. I'm navigating to the Kinesis console and saying I want to create a new Kinesis Firehose delivery stream. So a delivery stream, I'm saying my delivery stream name should be Summit Stream, okay? And I'm coming down, I'm telling it how do I want to store the data. How do I want to store the data? And I say next. It's asking me, do I want to make any changes to the changes using transformation? So I say next. So just give me a second, guys. I think I'm having network issues. So usually at a conference that is this big, there are some of the other small issues that we face. So just bear with me for a few seconds while I fix the internet connection that we have. All right, looks like we are live again. Thank you for your patience. So we go ahead and create a Kinesis Firehose delivery stream. We put the stream name as Summit Stream. And I'm telling it that I'm going to put the data directly into the stream, right? I say next. It's asking me, do I want to transform the data while it is in the pipe? I say no, and I do next. Remember I told you there are 4 endpoints that you can put the data in S3, put the data from Firehose. So we'll be choosing S3 in our case, right? And what is the bucket where I want to store the data? So if I go to the bucket, I'll choose the bucket name as Unni demo bucket. And what is the directory where I want to store this data? So I'll be calling it raw data raw, right? Because my data that I'm putting in is the raw data that I'm dealing with the demo. So I'll go ahead and click next. It's asking me how frequently do I want to dump the data from Firehose to S3. So I'll say either 1 MB or I'll say 60 seconds. So whichever comes earlier, it will dump the data. I'm going to use no encryption, no compression for the demo. And I'll create an IAM role so that my Firehose has the access to go and dump the data into S3, right? So I'll allow Firehose to go and dump the data into S3. I'll go and do next. And I'll just review all the settings that are here, right? So I said, what is the stream name? This is the S3 bucket where the data is going to go. And the data is going to get dumped into S3 every 1 MB or 1 minute, whichever comes earlier. And we'll do create delivery stream. So this should take almost approximately 1 minute to spin up. In the meantime, I'll take you to the AWS S3 console and show what is happening there, right? So I've already got an S3 bucket that I've created for the purposes of the demo. And I've placed some reference data in there. But that is not the raw data that we'll be using. So under the data folder, if you see, there is a reference data folder. So this data has information on what is the music, who is the artist for the music, and what is the track ID of that particular song, and what is that my smart headphone user is listening to, right? So once we dump the data, we should be able to see another folder called raw data in here, and that will come in, right? So it looks like my Firehose should be spun up by now. So if I refresh this page, it should show active, right? So it shows active here. So let me go to my Kinesis data generator. So this is a tool that was built by our Kinesis team for generating dummy data so that you can play around and test Kinesis, right? So I'm going to log into my Kinesis data generator and generate some raw data or for the demo. So we'll be using the region US East 1. So US East 1, and the delivery stream is Summit Stream, right? I'm going to be a bit mean and send 2,000 records per second, right? And the data that I'm sending here is basically a random UID. What is the timestamp on the device? What is the temperature of the person who is wearing the device? And what is the activity type? Is the person running, walking, or whatever, right? And then I'm sending the data in here. So I'll send the data. And what will happen now is it will go and send the data into Firehose. And Firehose will be able to send the data into S3 and make it available for analytics. So let's stop the Kinesis data generator and see if the data has the data come to Firehose, right? So we will refresh here. We'll just wait, make sure that everything is OK. Come back to S3 and refresh this page. So the data should have come here, right? So the data is here. So we have the raw folder. And inside the raw folder, I should have data that is 1 MB each. If you see this bit here, sorry about the font size, guys. So if you see this bit here, you have the data, and you have the date, month, day, right. So we have the year, month, date, and the hour of the day when the data came in, right? So each file is 1 MB. So with that, we have ingested the data and stored the data. The next thing to do is, how do we go ahead and catalog the data? AV team, can I have the screen switch, please? Thank you. So now we have ingested the data, stored the data into S3. The next thing to do is we need to catalog that data, right? When I say catalog that data, I need something that will go ahead and scan my data. So that is where we'll be using AWS Glue. So AWS Glue is a service that you use to crawl your data, catalog your data, and transform your data using serverless ETL. That is extract, transform, and load, right? So a Glue crawler, what it will do is, it will go in and you can point it to an S3 bucket or any database that can talk in JDBC. You can point the crawler to that particular data source, and it will go ahead, scan the data, infer the schema. So that is the most beautiful thing about Glue crawlers. So it will infer the schema, tell what is the format of the data, and then it will go ahead and create a catalog of that data, right? Once the catalog is created, you will go ahead and write a job to transform that data. So that transformation bit is what we'll be calling ETL. And using Glue, you do it using a serverless. Glue is a serverless technology, right? So Glue is backed by Apache Spark, and it gives you a completely managed environment to run your job, right? So with that, let's take a look at how would this affect our demo architecture. So with the demo architecture, what we'll be doing is we'll be creating a crawler. That crawler will go ahead and crawl the data in the S3 bucket, write it to the catalog. Once the data is available in the catalog, you would be using the Glue scripts to run a transformation job and write the process data into the S3 bucket, right? I hope you like, guys, the animation. I spent 20 minutes building that animation. So team, can we have the screen switch, please? Thank you. So all right, so we are back in the AWS console. Let me show. So I showed you the data that has come in from Firehose and into S3, right? Let's go to the AWS Glue console and create a crawler. So this is the AWS Glue console. So currently there are no tables here because there are no tables here, right? Because I haven't created any crawlers. So I'm going to create a crawler, and I'm going to call the crawler like Summit Demo Crawler, right? And I'll say next. And I'm telling it what is the data source that I'm interested in, right? So the data source is sitting in S3, and which folder is the data sitting in? So my data is sitting in the Unni Summit Demo folder, and inside the data bucket, inside the data folder, right? And I'll go next, click on next. It's asking me, do I want to add in something else? I said no, and give access to Glue to go and access my data, right? And I do next. And I want to run it on demand. And it is asking me, do I want to create a database? So obviously, I want to create a database, and I'll call it SummitDB, right? And I create it and say next. Once everything is done, I'll do finish, and I'll click on run the crawler now. So this should take approximately 20 seconds. What it is doing now is it is going to my S3 bucket, looking at the data, opening the files, figuring out what is the format of the file, figuring out what is the format in which my data is set up inside the file, that is the schema of the file, and come back and update the crawler, right? So by that time, in this meantime, I think it should be done now. It says 21 seconds running. So we'll go to table, and we'll just be like impatient and keep hitting refresh. All right, cool. So we have the data in here. So we have the data that is, it has identified that there is a raw table in my S3 bucket, right? So the raw table in the S3 bucket is there. And with that, I'm able to see that there are these fields for that S3 in that S3 file, right? If I go back and go to reference data, I should see that the reference data has these particular fields. So it has a ID, it has, sorry, this is the raw data, sorry. So raw data has all my ID, timestamp, temperature, and stuff, right? With the reference data, if I go and do reference data, it should show me my reference information, that is a track ID, name, and the artist name. So let me quickly go ahead and transform this data, use a job to do it, right? So I'll go to create an add job, and I'll say submit demo. Go ahead and create a use the existing role, and say next, right? Sorry, I'll just use an empty script for the purpose of the demo. We'll do next, next, and finish, right? So what it will give me is it will give me an editor where I'll be able to write my job. Let me copy some code and put it in the editor, right? So I'll go ahead and copy this code into the Glue editor and see what it does, right? So Glue editor has a very cool feature where it can actually look at your code and infer what you're trying to do and build a diagram. So if I save this and click on generate diagram, it will go ahead and create a diagram for me and telling me what I'm doing, right? Let me quickly run you through what I'm doing. So I'm taking reference data, I'm taking the raw data, joining both of the data, dropping unnecessary fields from it, and then storing the data back into S3, right? So I'll be going and running this job now, but instead of running it from the console, I'll be running it using a Zeppelin notebook. So Zeppelin is a tool from the Apache ecosystem that is used by data scientists to explore and write data science jobs, right? So I'll be using my development notebook and running the code here. Let me quickly run you through what I'm going to do here, right? So I'm importing the libraries. I'm going and telling Glue that, Glue, go ahead and read the data that is there in the SummitDB database. And the name of the table is raw, right? And I'm printing the schema of that data. So this is the schema of the data, right? Now I'm counting how many rows did I ingest. So I ingested 30,000 rows. Now I'm taking the reference data, telling Glue to go and read that data. Once everything is done, I'm again counting the reference data, and it is 100 records, right? Now I'm applying a transformation called join, which I'm joining the raw data with the reference data, and the new schema looks like this. And because there are a lot of unnecessary fields here, like partition ID and stuff like that, I'm going to let go of that and drop those fields. Once those fields are dropped, I'm going to write the data into S3. So if you see this, this is what I'm doing. I'm saying write the dynamic frame. Dynamic frame is a data structure in Spark. Write the dynamic frame into S3, and this is the path where I want to write the dynamic frame, right? And once everything is done, I'm again writing a small bit of Python code here to go ahead and update the catalog. So I think by now the catalog should have been updated, right? So it says that the tables have been updated. So if I go down now, if I go to the Glue console again and look at the catalog, I should have 3 tables sitting there, right? So now I have raw data, reference data, and process data, right? So we'll go back to the main presentation, and we'll look at how we are going to analyze this data and also visualize the data, right? So far what we have done is we have generated the data, brought the data into the cloud using Kinesis. From Kinesis, the data came into S3. We used the crawlers to crawl the data from S3, update the catalog, ran an ETL job, had that job process the data and dump the data into S3 again, right? Now we need to find some way to run SQL statements on it so that we can analyze the data and visualize it using some visualization tool, right? So for analysis and for analytics in AWS, there are multiple options available, right? So Amazon EMR is a managed Hadoop offering. So if you're looking for tools like Apache Hadoop, Spark, Hive, Pig, and tools from the Hadoop ecosystem, Amazon EMR allows you to run Hadoop in a managed fashion, right? And or if you're looking for a simple data warehousing solution that will help you draw reporting, do reporting, draw dashboards, you'll be looking at Amazon Redshift. So Amazon Redshift is a petabyte scale a data warehousing service from AWS, and which is fully managed, right? For this demo, we'll be using Athena. So Athena is a very interesting analytics tool, right? So you have data sitting in S3. How do I go ahead and access that data using SQL without actually launching a database? That is what Athena solves. So Athena is an interactive query service that gives you access to your data using SQL statements and directly data that is sitting in S3, right? So let's take a look at how it looks, how it affects our demo. So we have the data sitting in S3. We'll be connecting Athena to that S3 bucket using the Glue catalog, and then we will use QuickSight to go ahead and visualize that. So let's go ahead and do the demo, and I'll quickly connect to Athena and show you how to do it. So this is the AWS console, and we will go to Athena, right? So I'm going to Athena now. Right? So on the left-hand side, you see that what are the databases that Athena can access, right? So there is SummitDB, and then there is process data table, right? If I open the process data table, there are a bunch of fields here. So I'm interested in the process data table. Let's take a look at, I want to know who was the most heard artist in my user group, in my user base, right? So I say select artist name, and I want to count how many times that artist name appeared, right? From process data table, right? And then I'll group by, sorry, I'll just add a variable here, and I'll say as count, right? So I'll say group by artist name, and we will, order by count, right? And we'll do a descending. So here we can get the data, and here you should be able to see the data that got collected, right? So here you are seeing that this particular artist called Imagine Dragons was heard 1938 times, right? So similarly, you can use this data in front of a Tableau or a QuickSight or something, and you can visualize the data, right? So with that, we are done with the part of the demo. What we will do is now we have the honor of having Daniel Muller, who is from Spuul, to come and share his story on how he built a data lake, right? So please give a round of applause for Daniel while he is sharing his experience. Thank you.
Oh, thanks, Unni, for the intro. So my name is Daniel. I'm the head of cloud infrastructure for Spuul. Spuul exists since 6 years. We're lucky enough to start our journey directly on AWS. So we were using only cloud since ever. So who is Spuul? Spuul is a leading OTT player. We are shipping Indian movies, TV shows, and live TV to over 50 million of users, and that around the globe, and on almost any device you can imagine. And adding to that challenge, we will start soon to provide non-Indian content also. So why did we build a serverless data lake? So we wanted to start to collect more than 100 events, and that they're coming from the devices, they're coming from microservices, they're coming from different AWS tools. We needed the flexibility of ingestion. When I mean flexibility of ingestion, means don't be bound to a schema. And we need the flexibility of consumption. That means that anyone can consume the data. You don't need a doctorate of whatever, a doctorate of SQL to be able to consume. And we didn't want to have to scale storage. For the future, we want to be able to provide this data to third parties, so be it internal third parties or external third parties. And most of all, we don't want to manage servers. So keep it trending, hashtag no more servers. It's like the theme of the day. So how did we build that? So we started with the ingest point API gateway that will feed the data into Kinesis streams. So the idea of API gateway is to provide a simple HTTP endpoint with our own custom authorizers. Then this Kinesis stream will trigger a Lambda function that will ingest either to S3 directly or to Firehose, depending on use cases. And Firehose will aggregate the data in 5 minutes, 100 MB, 5 MB files into what we call our raw storage. This raw storage then again triggers something that will combine all the data to build our final data lake with the whole fledged data. Then comes into play the glue crawlers. They will catalog the data, transform it eventually to Parquet, or the data lake could be read directly from Athena, or even be shipped to Elasticsearch or to Druid for direct analysis or API integration for third parties. The Parquet storage, which is a transformed data from our data lake, can be fed into Athena and Redshift or Redshift Spectrum for bigger analysis, long-term storage. The first Kinesis stream also allows us to do real-life data processing through either analytics or the tools, and then feed CloudWatch alarms or CloudWatch metrics to get info about things happening on our apps in a real lifetime. So that's like really quickly explained. It's a bit more complicated than that. But the lesson learned about that is to be able to manage all these little Lambda functions, use a framework. Don't start to have your scripts left and right. Be it SAM, serverless, or Apex up, doesn't matter. Just use a framework. Keep the raw format data all the time so you can replay, you can debug. Convert your data to columnar format. That allows you to minimize the number of data transferred to your end tools. Partition your data. Again, that allows you to select only what you need. Be it partitioned by date, which is the default, or even add your own filters. And when you do selects, don't do select star, specify the columns you load. The less columns you load, the less data you have to transfer. Create files of about roughly 100 MB files in your buckets. That will allow to reduce the number of S3 API calls. The data, compress the data in a data lake, that will reduce your cost of storage, but it doesn't add much on the cost of uncompressing it. And use Lambda for all the automation. You have a file that receives in S3, trigger Lambda to do something. And with that, I've done my part, and I give it back to Unni.
Thank you very much for doing that, Daniel. And this is a small token of appreciation from AWS side. Thank you very much. So with that, guys, I wanted to summarize the session, what we learned today, right? So it's all about 4 things. Think about how you're going to ingest the data. Think about how you're going to store the data. How are you going to catalog and transform the data, right? Once you have figured out all of this, then what you create is something called a serving layer, right? This is the layer where you'll be serving the data out to the different users within your company, right? So thinking about data lakes, storage, to make it future-proof, think about security, think about cost, and think about the central storage system that you'll be using, that is Amazon S3, and how you're going to build the tools around it to build your data lake, right? So with that, thank you very much. I really appreciate your time for coming down today and attending this session. And please do fill your feedbacks, and your feedbacks are very important for us. Thank you very much, and have a good day.